Okay, problem number 49 talks about labeling conjugate acid-base pairs for a particular problem set in number 48. This is from your textbook. I believe it is on page 591. So if you want to go back there, you might want to do that and follow along if you can't see this very well. Okay, but this is a pretty good description of what a conjugate acid base is. When you look at this particular equation up here, all right, when you add ammonia, for example, to water, okay, ammonia to water, you're going to form an ammonium ion and a hydroxide ion. As you think about this right here, okay, they consider here in this particular case water is going to be the acid, and your ammonia is going to be the base. Okay, now why does that happen? Well, if you guys remember with respect to water, okay, this is the Lewis structure for the water, and I got my unshared electron pairs, okay? An acid, if you remember being a proton donor, if an acid is a proton donor or hydrogen ion producer, okay, one of these hydrogens right here, okay, actually one of the protons from that particular hydrogen, okay, since there's only one proton, that one proton, when that leaves, what you're left with here is going to be this OH, polyatomic ion with the minus, which is my hydroxide ion, okay? And you're going to have this one proton, which is going to be my H+, okay? So that's why water can act at times as an acid. It can also act as a base, depending upon the situation. So when you look here, this is why this is my acid, okay? Why my water is my acid or my proton donor. Now we're going to erase a bunch of this stuff here. And we are going to consider why we have over here my ammonia as my base. Well, when you think about ammonia here, this is the Lewis structure for ammonia, and you guys should remember all this kind of stuff, and I know that you do if I were to ask you, but I've got an unshared electron pair right here. Now, this unshared electron pair will readily accept a bare proton, which would be that H+ from my water that we talked about a few minutes ago, that bare proton, because remember, that's all that is. And that will associate itself with that particular unshared electron pair to form, once again, this will be the ammonium ion, which will have that positive charge. So that's how this particular thing, the ammonia, is the base. Okay, it will be the proton acceptor. So you have a proton donor in your acid and a proton donor in your base. Well, so how does that help you understand those problems with respect to the conjugate acid-base pair? Well, if you notice on the right-hand side of the equation over here, on this particular right-hand side of the equation, right over here, okay, what you end up making with that, when you make the ammonium ion, remember, an acid is a proton donor. Well, that ammonium ion is going to have a positive charge, a net positive. So on the right side of that equation, that becomes a conjugate acid. Okay, all right. On the right side of the equation, that hydroxide, we always know the hydroxide is a base. You know, an aqueous hydroxide is going to be considered a base. So that becomes my base. So what we have here is we have on the right-hand side a conjugate acid and a conjugate, what we call a conjugate base. Okay, and the way you pair these things up, if you look below here, okay, when you look below over here, we have our base will be paired with my conjugate acid. So my base on my left side is going to be paired with the conjugate acid on the right side, and my acid on the left side is paired with my conjugate base on the right side. So that's how you're going to answer that question number 49. Don't make those difficult. Look to see which one is the acid and which one is the base on the left-hand side, and understand that the base is going to become the conjugate acid on the right side, and the acid will become the conjugate base on the right side, and they'll be paired like this. Extremely, extremely simple.